to reveal our add-on within Blender, you hit N on your keyboard and it shows you this panel here that we've made. And the objective is to be able to attach attributes to objects in the scene. So here I have a wrench. Currently it has no attributes listed. It tells you here that I've selected the wrench as well. If I go ahead and click add for VR grabbable, and if you notice when I hit VR grabbable, there's also the options drop down because this specific attribute has more configuration that's possible. So I'll just hit select this option, hit add attribute. As you can see, the list gets updated, and there's also the option to remove it. If I add equipable, for instance, I can also remove it here. It's also in the list. So if I just remove equipable just to demonstrate, it's in the list here. Click remove. It's gone from the list. So that's adding, removing attributes. And then to export, you just put in the directory here and the file name. Select the format. In this case, we use GLB pretty much all the time. And then you export. You can export the entire scene or individual assets within the scene. So in this case, you have the camera as well within the scene and the light as well. As you can see here, selected object. But for this, we just export individual, and it should show up here. So we have the wrench, light, and camera, and this is our wrench object. I'll just double click to confirm. Okay, so the wrench object is here, and then this gets uploaded to the Motive server, and then if you run the scene within Unity, it downloads it into Unity and applies. So we did already upload it, and we're not going to show it in the demo, but it has the VR grabbable attribute on it. And so if I run this scene here in Unity, I can go up to the wrench, and if I just move my hand there and grab, I'm able to grab the object within Unity.
Hi, welcome to Motive C project presentation. Our project is aiming to minimize the friction of creating VR experience. And the software we are building on are Blender and Unity. Blender is a free and open source 3D asset development platform with a strong foundation of modeling capabilities. And Unity is a 3D storyline creation engine with many of the most important built-in features that make a game work. In our project, we created an add-on divided into Blender and Unity side, which is linking the both software. It allows artists to export assets to Motive server from Blender, and it's able to add and update custom attributes to the objects. Then the attributes are passed to Unity with the assets. And our target users are mainly divided into two portions, which are Blender side and Unity side. As for Blender side, our target audience are professional 3D artists. An example scenario can be that Motive company gets a project to create a VR game. The tasks are passed to a department which is working on 3D modeling part. Then they work for groups of assets for the game and using our Blender add-on to provide an extensible layer, like adding or updating attributes to the objects. And the assets can either be exported directly as GLB files or exported to Unity Motive SDK for VR scene development.
Target user groups for Unity side. One group is Unity developers and the other group is Motive customers. One example scenario for Unity developers are when Motive is trying to create a VR game and one department is working on Unity development. They will want to create VR scenes with given 3D assets that were made in Blender. So our software is to make their work easier and make 3D assets made in Blender fits into Unity faster and easier. For Motive customers, they will not directly interact with the software, but the VRScene presentation could include assets that were made through Blender add-ons before being processed and rendered by the UnitySide add-on. The requirements for a project mainly contains two parts, functional and non-functional. The functional requirements ensure that the software works and can perform all tasks required. The non-functional requirements ensure that the software is user-friendly and won't have any negative impact on the workflow. The functional requirements are attach components to asset, version tracking, and file specification. Components can be selected to attach runtime import and export to GLB format. Non-functional requirements are native add-on construct that does not have a significant experienceable delay during operation and function expandable. The design for a project has two parts, Blender part and Unity part. The Blender part is mainly for assets export and adding components, and the Unity part is mainly for assets import and create VR scenes. Therefore, we create a panel in Blender that allows artists to add components and export assets in any form they want. For the Unity part, we mainly added the Motif SDK to make it work properly. As a result, our software passed most testing and all features required to meet minimum functionality have been implemented.
Now we explore our key functionalities. Through exploring, we were able to attach attributes directly into the GLTF/GLB file format for our custom add-on, passing it as extra variable in native GLB formatting. Within our add-on, the exporting to GLTF and GLB are easily interchangeable depending on the use case. If there is no need for a bundled binary asset, then GLTF can be used. Otherwise, GLB will be useful for passing 3D assets to other platforms post-production. Considering the potential need of passing assets to other platforms, we ensured our assets were compatible and compliant with native GLB formatting. We verified the validity by uploading the assets to the GLTF/GLB validator made by Kronos Group, the developers behind GLTF file format, which all the tests for the assets passed. By utilizing native functionalities, our asset export can be used not just in a particular use case, but extended out to the other engines or platforms as required. As such, in our add-on, the users have the option to export these objects to other VR creation platforms besides Unity, such as Unreal Engine, when upon export the coordinate system is modified accordingly to the destination platform to allow for a smoother transition and compatibility with the assets is used in animation. Then utilizing the GLB parser we've developed, we can extract and attach the desired attributes, fulfilling the intended workflow of the artist and their clients. We discussed our technical challenge that we faced. One of our biggest technical challenges was to have the exporting done in native GLB formats. Our original design included a two-part export from Blender add-on. The add-on would export in binary asset and a configuration JSON file containing the attributes that were attached to the object. The Unity side required to read in both the binary asset and JSON file to attach attributes accordingly, added unnecessary complexity and the need to import multiple files, and extra components that would make the project more complex than it needed to be. Thus, we explored the GLTF/GLB option to come up with an implementation method that allowed us to attach our attributes in the native fields of the binary asset, removing the need to rely on a two-part system containing binary asset and config JSON file. In Blender side, we needed the file to read the extras and display to the user if the asset already has existing extras. The user would need to be able to modify each attribute upon exporting. The asset needed to reflect each change the user made and have the settings set in Unity accordingly. These took considerable amount of time and effort to have configured correctly, where we faced challenges changing the GLB file format itself and pass validation, then to come up with a method to pass and allow for extra fields to be interpreted correctly, not to be confused with native GLB or extras or attributes from other plugins, while allowing for the attribute to be read and written in Blender as well as exporting and recognizing in Unity. This issue was solved with attaching custom labels onto the fields that both add-ons recognize upon processing. For part of our transition, our Unity add-on is included within the Motif SDK's own binary asset loader file, allowing for a quick setup and utilization of our add-on once the project is loaded or initiated. Both instructions can be found within report installation file. There are no additional configuration required for the Unity add-on to work. All functionalities are included as classes with binary asset loader to load binary assets into the project, instead of using the utility GLTF from Khronos Group to manage our binary asset loading, we opted for a third-party plugin GLTF utility. The GLTF utility provided the same functionality as the Khronos Group's utility, but is more efficient, easier to install, and utilize from within the project. Our Blender add-on is developed according to the guidelines and formatting of a standard Blender extension. The standard allows for our add-on to be a plug-and-play experience after a small installation step or not installing at all. The add-on can be installed manually via directory copying or launching it straight from VS Code with the help of Blender Development plugin, the details of which is outlined again in the report. The Blender Development extension used in our project is open sourced and part of the Blender Development Fund, making it easily accessible and customizable should future needs arise. The plugin is actively maintained and supports the latest version of Blender available. In summary, for the Blender extension, the work to be done would focus on UI refinements to allow for a better workflow and further expansion as the project grows. As part of our expansion, reading attributes from external sources would be implemented and have attribute attachment and configuration per individual component, expanding the scope and functionality of the add-ons as future use cases evolve. In Unity side, the binary assets will require the following features to be implemented: configuring motive usable objects and configuring proper joints for multi-component items. To allow for more complex objects that a user can interact with, such as a computer or camera, the motive usable objects will allow for more specific configuration scripts as required in the scenes. And that concludes our presentation. Thank you.